Okay. Any word from the other two?
I just know they're not here.
Okay. It'll just be you and me then tonight. So what we'll do, we are just going to continue on with the chapter 4 slides, but some of them are going to deal with Excel. So that's why I'm going to be using the screen up here tonight. But let me just get the slides here. Just because we got right to Excel the last time. We'll see if it wants to do this. There we go. So the thing with Excel is that there's going to be some different functions that you can use. The first one they give you is a future value function. So this would be for problems like, say you start off with $1,000 and it compounds at 5% per year. How long could it take to get to $2,000 is an example of where you would use that. They give you a little spreadsheet here that you'd be able to use for that general formula there on the previous slide. But if you fill in all of the information in the yellow boxes, you can do formulas in Excel. Have you ever had to do formulas in Excel before?
A little bit, but not too much.
Okay. Yeah, the big thing with those, they always start with equals, and then it's going to be whatever the operation is. So if you were adding two things, it would be like equal sum. Or if you were multiplying, it would be equals product. Or something along those lines. But this leads into another term, APY, which is going to relate to APR, which is the annual percentage rate. Last week when we were looking at compound interest problems, we had a formula that looked like this on the next slide. APR was the annual percentage rate, so that was the interest rate that you were getting on that there. But APY is the actual percentage by which a balance increases in 1 year. So in other words, it's the change in terms of percent of how much an account goes up in 1 year. So if compounding annually, that means n is equal to 1 in that case. These are going to be the same. If compounding is done more than annually, so say like every month or every day, APY will be greater than APR. But the reason why API is useful is that it allows you to compare interest rates with each other without doing any type of like division. can also be called the effective yield for an account. So they have an example here. So you have $2,000 to invest in a savings account. You can choose from the following two. Bank A offers an APR of 8% compounded quarterly, and B offers an APR of 8.4% compounded monthly. The question is, what is the APY for each bank? But we could figure this out. So A equals, the starting amount was
2,000.
2,000 times 1 plus the first bank would be 0.08. If it's compounded quarterly, N would be how many done in a year if it's quarterly?
Would it be 4?
Yeah. Yep, so that's 4 raised to the 4 times 1 power. And there you can do the inside parentheses first to get 1 point.
I got 1.08.
1.08 when doing the exponent or just the parentheses
I
inside?
did the parentheses and exponent.
Okay. Yeah, because inside that would just be 1.02, right? Just because it's that divided by that first, and then plus the 1. And then from there, 1.02 to the 4th.
Mm-hmm. 1.08.
And does it keep going after that by chance?
1.08243216.
Okay. So then if we multiply that by the 2,000,
$2,164.86.
okay. Yep, so that's figuring out the final balance there. But APY is the absolute increase. So if we started with 2,000, how much did we go up?
$164.86.
164.86 divided by the starting amount, which is 2,000.
Oh my God. 0.08243.
0.08243, or as a percentage, that would be 8.243%. You're able to see that, right? Okay. Wasn't sure if I was going over too far or not. we have that. The second one, Bank B, offers an APR of 8.4% compounded monthly. So 2001 plus 0.084 divided by 4. If we're compounding it monthly, what would N be there?
Would that be 12?
Yeah. So that's really 12 raised to the 12 times 1 power. So 0.084 divided by 12 plus 1.
I got 1.007.
Good. To the 12th power then.
One 1.09.
At 1.09 if you rounded. Something kind of like that. Okay, multiplied by the 2,000.
$2,174.62.
So 2,174.62. So APY be an increase of 174.62 divided by a starting amount of 2,000.
.08731.
So 0.08731 or 8.731% for an APY. Any questions on that example?
No.
Okay. Okay, and just like we were dealing with some of the other Excel things, you can find APY in Excel as well as APR. APY is the equals effect formula there. APR can be found by equals nominal, parentheses, the other one. So if you're looking for APY, it would be APR in parentheses first. If you're trying to find APR, then the first parentheses would be APY. Second one's always N. So number of times it compounds within a year. And I know last time we were talking about CDs, certificate of deposits. Were there any questions about that from last time?
No.
Okay. Yep, so essentially set aside amount of money, typically to the bank that you use. They keep it safe. They give you a higher interest rate for a certain amount of time. You can't touch it until that time is over, though. If you do, there's usually an early withdrawal penalty. But just to give you an idea there, CDs are typically around 4%, maybe 4.5% if you're lucky. You know what the typical interest rate is for a savings account at a
I
bank?
don't.
No,
No.
it's usually 0.01%. So, in other words, you're going to get a lot more interest from one of these than traditional savings. Now, the next one here, there's usually some conditions that go along with these. Like, for example, the 8-month CD. You need to have $500 to open it and keep a minimum balance of that in there to get the 4.5%. So if you fell below the $500 balance, then they wouldn't pay it until you got that amount higher than 500. But just make sure to read the fine print like that there. Like down there where my mouse is. So like the 6-month destination one, kind of an interesting thing there. $2,500 in new money is required to open. Money must not have been on deposit at Reliance Bank in the last 30 days. So that condition is that it's brand new money that they haven't been working with. But this gets us to the next part of the chapter here, which is going to be getting into investments. Once you graduate, get your degree, start making money, you typically are going to want to look into some type of retirement account. Typically, the IRA is a good one. There's a Roth IRA out there as well. I'm not sure if you've heard of either one of those before.
I've heard of the Roth.
Okay. Pretty much the difference between the two, it's when you pay the taxes on it. So the traditional IRA, you pay the tax on it later when you take the money out. With the Roth IRA, you pay the taxes now, but then when you take it out later, it's tax-free. So generally, if you're younger, they say the Roth is the better one to go for. Some of them may have annuities, which is basically a regular payment for keeping your money in that account. There's always a college savings plan, 529. That might be for if and when you decide to have kids or a family. But savings plans, to figure out future value, it's going to be based on the compound interest idea. So based on that formula that we were working with above there, and again, there are more specific formulas that are on the screen up here. But let's be honest, they're kind of a lot, aren't they? Yeah. So as far as this class goes, the only one of these formulas that I've seen show up on the exams is the compound interest formula, or even the continuous one where it's P times e to the RT, like that formula. I generally haven't seen future value or regular payment show up. But if it did, you'd be able to use Excel to get these. So there's the future value function that you'd be able to type into Excel. And again, interest rate divided by number of times it compounds in a year is the rate. N per is whatever N is, the number of times it compounds in a year, times Y, so the amount of time. PMT is the regular payment amount. So say you were depositing $100 a month. 100 would go in for payment there. PV is present value, and the type is when the payment is made. Generally, you don't have to enter anything for that. What it means, though, is do you pay it at the start of when it compounds or when it ends? So if it was compounding like monthly, it would be, do you pay it at the start of the month or at the end of the month?
Start.
Typically, yeah. But depending on when you do, that's what would go in for the type there. Okay. And again, they have an Excel sheet here that has these different things that you can type in. You can enter the formulas for compound interest to compute the rate and the number of compounding periods. And then using that future value function, you'll be able to get the future value. And there is a function for regular payments. I think we were just talking about that. But are there any questions about any of the Excel pieces?
I don't think so.
Okay. Let me just make sure I don't have any questions from everybody on the line. Okay. Okay, so 3 types of investments: cash, bonds, and stocks. Cash is basically cash money, probably something that you use fairly often. Bonds act as a form of debt. So in other words, you don't get anything, but you're getting a promise of future cash later on. Stocks mean that you purchase something and you're getting something in return. Typically ownership in a company of some kind. You make or lose money depending on what the price of the stock is. Have you ever looked into stocks or bonds or anything like that?
Not really.
Okay. So essentially, what would happen, say you were going to buy a share of, let's say, Tesla. You can buy it right now for, I think it's like $400 and some a share. So say you buy a share of Tesla, you own a fraction of the Tesla company when you buy that share. Say Tesla does really well and the stock price goes up to $1,000 a share. You just made $600 in the process. But say Tesla doesn't do so well, it goes down to 200, So now you lost 200 from where you started. But no matter how you invest, always three things to consider. So liquidity, or how difficult will it be to get your money out of what you invested in? Next one is risk. So is it at risk? How much risk are you willing to deal with? And then return, how much more can you expect to get from your investment? Those are pretty much the three things that you'll want to keep in mind there. The reason I point out stocks, just looking at this chart here, what's the overall trend? Like as time goes on.
It kind of looks like it's increasing.
Mm-hmm.
No, I'd say it's like positive.
Mm-hmm. Yep, so positive correlation there. But the interesting thing, on the y-axis over here, like on the left, do you notice that the values are doubling with each square there?
Oh, yeah.
So this isn't actually a linear progression here. It's actually exponential. But the interesting thing here is that, say from 2015, it was 16,000, where my mouse is. In 2020, it was almost 32,000. So this graph is kind of misleading a little bit on how much it's actually going up. It's actually going up at a much steeper rate if this would have been a linear graph. But the reason that I point this out here, on average, stocks always go up in the long run. Now, when I say long run, I'm talking 10 years plus. Like, for example, if you invested in something back in 2010, it would have been about 8,000 on this graph. In 2020, it would have been 32,000. So you would have made 4 times your money in 10 years. And there's 2 ways to make money at stocks. Capital gains, which is the profit that you make, essentially, or dividends, which is when that company decides to reward the people who own shares of their stock. So what that means, say we go back to that Tesla example, you buy a share of it at $400, and Elon Musk, the guy who runs that company, decides, I'm going to give you $5 just for owning this share of stock. Companies will pay out things like that every so often in order to encourage people to own their stocks or to hold on to them. But there's a lot of things that go into understanding a stock quote. That slide has a lot of information on it. But whenever you're looking at a stock market quote, Each stock has a couple of letters to indicate its symbol. The now price is what it's trading at. So in that case, the 240.97. Change is how much it went up or down that day. Percent change is just the relative percentage. So in that case, down 1.16%. Volume is how many shares of stock were traded that day. Open is how much it was at the start of the day at 9:30 in the morning. High was the biggest price it was all the day long. Low is the lowest price it was. The 52-week high is the biggest price it was in the past year. The 52-week low is the lowest price it was in the last year. And they have other things in here that get into more of the business side of things. Market cap will tell you roughly how much the total company is worth. PE ratio, or price to earnings ratio, just tells you how much the share price is divided by the earnings or profit per share. Dividend latest quarter, that's how much they paid you to have the share of Microsoft. So in this case, 56 cents. Dividend yield is the percent of how much the share was. Shares outstanding, the total number of shares of stock that exist for the company. So I know there was a lot going on there, but any questions on anything? Everything good? Okay. Okay, then we get to bonds. Three main characteristics: the face value, which is how much you pay to get the bond; the coupon rate, which is another term for interest rate. They calculate it using simple interest, or interest equals principal times rate times time, or I equals PRT from last time. And then the maturity date is when you're able to claim the money on the bond. There are mutual funds. Generally, mutual funds are a collection of stocks and bonds together that are run by some type of company. So, an example, since we were talking Tesla, Tesla is only one company. Say you thought that was too risky to invest in just one company. You could find a mutual fund somewhere that might have 100 companies in it. So that way, the success isn't determined by just one company. You have more of a diversity going on there. There generally are some fees associated with mutual funds because another company is running it. And it could affect how well it performs relative to everything else. Mutual funds look the same way that stocks do on the stock market. The only thing is when you see an X at the end of the symbol, like over here, if there's an X at the end of the stock symbol, that means it's a mutual fund. So that's just a quick way to tell if that's a mutual fund or not. So the net asset value, NAV, that's how much it would be to buy a share or a bond. It gives you the total return over certain periods of time. YTD, that means year to date. So in other words, from January 1st until I think today is September 30th, right?
Yeah.
So the total percent change from January 1 to today of this year is what that is. Any questions on how mutual funds work in this system? Okay. Then we get to loan payments, credit cards, and mortgages. So whenever you take out a loan or do anything like that, always a principal or the amount of money that you borrow, the loan, which is going to have regular payments, and the loan term. So in other words, if it's a mortgage, it's typically going to be a 15-year or a 30-year mortgage. So you'll be making regular payments every month for 15 or 30 years with those loans. Again, there is a formula to figure out a mortgage payment or a loan payment. But again, it looks kind of obnoxious looking, right? So instead of doing that by hand, we can use Excel. The regular payment formula is equals PMT. That general function there will get you the regular payment if you have all those other information. Rate is the interest rate per compounding period and per total number of payments, PV present value, FV future value, and you want that to be 0 for a loan. Again, Excel sheet with that information. You can just fill in the numbers for each of those. And then we can enter the formulas to get those two, and then payment function to get the payment amount. Any questions so far? Okay. So this gets us to a type of loan that you probably have to deal with to some degree. Student loans. So there are federal ones that come directly from the government. They're direct subsidized and direct unsubsidized. There might be a plus loan there, but they have fixed interest rates associated with them. And you have to do certain things Like, I'm willing to bet you had to do something with the FAFSA. Yeah. That usually determines a lot of this kind of stuff here. Depending on your situation, you might be able to get a deferment once you graduate. It's usually about 6 months or so. So they give you about 6 months or so before they start asking you for payments on them. But whoever you're getting your loans through would have more information on that. But this leads us to an example here with student loans. Suppose you have student loans totaling $30,000 for when you graduate college. The APR is 6.53% and the loan term is 10 years. And what we can do here, we can use Excel for this. I'm just going to write this formula up here. Rate N per CV FV type. So rate is R over N, N per is N times time. Present value, face value would want to be 0. So I'll just go to Excel and type this in. We'll see what happens. So equals payment. The rate in that was what, 6.53%? So 0.0653. How often is it compounding? What's that? In 10 years? Okay, but is it compounding annually, quarterly, or doesn't it say? APR, so it would just be 1. Okay. And per over 10 years, right?
Yeah.
So that would be 10. The present value of the loan was 30,000, right?
Yeah.
Face value, we want to be 0. And payment is timed at the end of the period. And it generally records it as a negative, so if we just flip the sign, so this payment here, the $4,179, that's how much you would pay each year. So divide that by 12. Looks like you're going to be paying about $348 a month. So that's monthly payment. How much will you pay over the lifetime of the loan? That's going to be the $4,179 times how many years? 10. So you're going to be paying $41,790.01. the next question here. What is the total interest you'll pay on the loan? So just that amount minus your starting principal. So it looks like $11,790.01 in total interest. And then in the first month, how much of your payment will be for interest and how much will be used to reduce your principal? Well, we're starting off at $30,000 on the loan. So 1 plus 0.0653. So this value that I got here, the 31,959, that's how much it's going to be at the end of year one. But what I'm doing here, we just want to figure out how much it's going to go up in that first month. So for the exponent, instead of 1 for 1 year, a month is only 1 out of 12 parts of a year, right?
Yeah.
So that exponent should be 1 out of 12 there. So that means at the end of the month, 30,000 goes to 30,158.56. But then say we take off the monthly payment. So in other words, there, 30,000 of it minus the 29,810.31. So $189.69. That is how much your payment went to the principal. And that 158.559 after the 30,000 over here. That was pure interest, right?
Yeah.
So that's going to be how much interest you got that month there. Kind of crazy, huh? The one thing about banks, they always get their interest first. But any questions on anything you see so far?
I don't think.
You don't think? Okay. So I think I'm going to have to stop here for tonight because I have to go over for something at 6:30. But we'll just do our next in-class assignment on Thursday, and then we'll go from there.